Good morning and welcome everyone to IGTV. All right, on with us today is Mark Kepis, and Mark is going to be talking about some basic network segregation and host hardening. Mark, go right ahead.
Morning, Joe. Today on Practical InfoSec, I thought I'd go over some basics regarding network segregation and system hardening. This may strike some organizations as fairly remedial, but I know with Stuxnet and some other things, a lot of people are struggling with this. And if you're in an organization that may not quite be as advanced and you tend to use things as the manufacturer ships them to you or go with the default setup programs, this will give you some starting places, and maybe it'll be some food for thought for some more mature organizations. So jumping into it, why do network segregation and system hardening? Well, it increases your system and network performance. The less things that you have running over your network, the less protocols, and the less things that you have running on your system, it'll increase your system performance. There are more resources available for your tools to provide your business automation. It lowers your risk and increases your security posture, because by shutting off things that aren't normally used for your business automation, you will shut down an entire set of available vectors for hacks and other attacks to utilize. It also aids you in observing and identifying anomalous and malicious activity. I spoke a couple weeks ago about advanced persistent threats. One of the keys to advanced persistent threats is finding the not normal traffic, the things that are out of place. If you reduce the amount of things that are on your network and the things that run on your systems, it is easier to get your signal to noise ratio much higher so that you can see things that don't belong there. In addition, it helps you reduce some of your cost because you're reducing the number of things that you need to update, manage, and patch. So your systems administrators can only worry about the things that you have running on your systems, and you can ignore the large swath of things that are thrown at you that don't apply. Going into network segregation, some of the physical separation of segmenting your networks and doing things like that. If you physically compartmentalize your network by function and level of access, the concept of network zones, you can think about either, basing certain compartments on your information classification or your usage type. If you have a bunch of database servers, maybe you want a database compartment. If you have some information that is highly critical, box that up somewhere that not everybody can get to it. Some of the compartments that I've seen in organizations or segmentation, you typically have, common office environment, workstation computers, mail and file systems will be a part of that, or there may be a subcompartment in that. Sensitive information storage, that ought to be separate. We're all familiar with the DMZ concept, so your internet servers, that sits out there in the DMZ, as well as you may want to create another, internal zone for your intranet and application servers. And on your back end, database servers and mid-range servers, as well as SCADA systems or control systems if you have them. If that's something that users don't directly touch, you definitely want to compartmentalize them away so that user networks can't see them directly. If you start talking about logical segregation, there are a lot of tools out there, with the advent of the switch, and that's kind of old hat now, but a lot of people don't use the stuff to its degree that it can. VLANs are your friend. You can separate different types of VLANs, and either by usage or traffic type. So if you want to dedicate VLAN traffic to your mid-range, your middleware traffic, you can do that so your user and your Windows shares don't start hitting that. So you can separate that by web or database or file and print. Your network attached storage. If you have network attached storage, you definitely want to dedicate that so you can monitor that carefully, because if anybody can see that, anybody can get to it. Likewise, we talk at InfoGuard a lot about physical access control and CCTV. As physical access control, like your building access, your card swipes on doors, things like that, start to use ubiquitous internet networks and are sitting on our office networks, you're going to want to control that traffic. And if you dedicate a VLAN to it, it helps you monitor that traffic and control the bandwidth. Some of the other considerations, understand what protocols are running on your networks. Understand how those protocols coming in and going out, either blocked by firewalls or border routers. Less is better, least is best. You don't want to be broadcasting ICMP between your segments or outside your network, as well as other things. Understand how your DNS is working. DNS is a critical footprinting tool for bad guys. So you want to understand how your internal zones and your external zones share information, talk to each other, and minimize the amount of information that internal zone is passing to the external. Disable routes to external zones for server farms. I'm a big advocate of this. If you have internal servers, chances are they probably don't need to see the internet ever. I know we all get, as we did last week, we get caught up with Microsoft updates and vendor updates. But if you can set up a bastion server within your organization to provide those updates to your internal servers, by cutting off that access, you're restricting a lot of attack vectors from hitting those servers. If the servers can't hit the internet, information can't go directly from the server out to the internet. Understand what your third-party connections have, how they're zoned and how they're bastioned, and what protocols they pass. And if there are protocols that you don't like that they use, shut them off and talk to your vendors and work with your vendors. Your vendors are happy to support you in working in your network. Sometimes you have to have a couple of conversations, but it's your network, your house, your rules. So set it up to your appropriate level of risk. Also consider using VPN internally for critically sensitive information. If you have certain HR systems or systems that are under HIPAA or other regulatory regimes that you feel you need good encryption around, consider using your VPN even internally to mask that traffic. Switching gears here and talking about system hardening, talk about slowing down the system. Apply the principle of least privileges for services and programs. We use it a lot for users. You can use it for other entities as well. Think of entities as not necessarily human users, but they do consume services and provide services, so you can think of them as entities. So apply least privileges to things that are running on your systems. Limit your services on your servers to only ones that are needed for your business automation. You want to limit that down so that a typical box standing up providing services within your infrastructure is only providing what is needed to do the business automation. So turn off file and print if they're not needed. Turn off protocols and services at the network interface. This is also a really good one for critical systems, especially if they have sensitive information. In Windows, Unix, Linux, you have access to that network controller in the configuration of the host. You can restrict protocols on that network interface in the advanced configurations. And it's very good to, if the server doesn't need to be surfing the web, turn off port 80 and port 443 on the network interface card. If you get hacked and even some malware rises there, if it's looking to use port 80, it can't because you've turned it off the network interface. So there's a really good way to short circuit a lot of attack vectors at the card. System and user, some user and group considerations. Rename and disable your default accounts. If you're using administrator and root, don't. You want to use unique identifiers. If you have system administrators out there doing SA work, you want unique identifiers associated with them. So give them a unique identifier that is an administrator or a root equivalent. Change and disable the default ones from the manufacturer, and most hacks will stop right there. They're looking for administrator. If administrator is disabled, it can't use it. Again, privileged user like SA or other power users, make sure you have unique identifiers so you can track where they've been, what they've been doing, and go forth with that. Application and service users should follow the same principles and policies that your human users do. I know this can be a bear to set up and can be a bear to manage, but you need to do it, especially because a lot of these systems, your database and other middleware runs as a privileged user. So you need to get in there and make sure that you can reset that password at 30 or 60 days or whatever is appropriate within your policy, and make sure that they have least privilege and they can write only what they can write and read whatever they need. With that, understand your log files. Part of, a lot of compliance regimes require that you keep these log files. Sarbanes-Oxley. Those logs now are transactions for those identified systems, and you have to store them and certify in a manner that you can vouch for their authenticity. So you need to understand how quickly your logs grow, where you're going to store those logs, and what kind of capacity you need. Do you need to get them off your systems and do external storage? Are you required to store certified logs? And how quickly do those logs fill or overwrite? And think about that for things like routers, proxies, and firewalls, because if you're responsible for the security investigation, those things typically give you the correlation to figure out how you've been attacked and what your possible remediations might be. And it will also provide you evidence if you need to take action, both either in court or otherwise, HR, etc. Some other system hardening considerations. Again, we talked about least privilege. Make sure your file systems follow the same thing. And make sure your access control list and your file system attributes match the profiles of your users and your systems entities. What are your applications required to read as far as the system, or read write? Do they need to really read write in, for a Windows box, do they really need to write into the Windows System 32 folder? Probably not. So only give them read access unless the thing really breaks, and then figure out what the minimum is. If there's a scheduler, batch, cron, what's in there, what needs to be in there, inetd for Unix and Linux systems. What are your device drivers and software that you need? A lot of the boxes now, when they ship from manufacturers, they come with all the bells and whistles and utilities for the video cards and everything else, and maybe you don't need all that stuff in there fattening your system. I mean, obviously, if you have a RAID controller, you need the RAID control drivers and the RAID management software, but for a lot of the other accoutrements on the machine, you don't need that stuff. So when you're re-imaging a machine, you might want to get rid of it. I'll have some more information on network segregation. I've got NIST has a terrific chapter on network architecture as part of their 800-82 draft. That's generally targeted towards SCADA systems. It might be overkill for your organization, but it's a good place to start, and a lot of the principles apply. So I would encourage everybody to read it. In addition, I've got some links from the Center for Protection of National Infrastructure in the UK. They have a general network doc and a SCADA doc. And again, the SCADA doc, while it's targeted for manufacturing networks and the manufacturing segregation, there's a lot of good principles there that can be applied for critical business, even if you're not doing manufacturing or control systems. Likewise, I've got some system hardening links, both from NIST and SANS, and that's Practical InfoSec.
Terrific. Good overview. And for anybody who's looking for a deep dive in that area, Mark is going to put some links up on the chat, as he normally does, because he does his homework for this. All right. And Mark, thanks for coming on the program and providing us all the details. We certainly appreciate it.
All right, more than welcome, Joe. Thanks.
All right. We'll see you next week.
Yep, see you next week.
Right. Bye. Okay. So.